the bonds between atoms. As discussed, as mentioned, as we briefly mentioned, the bonds that hold atoms inside a solid metal are known as metallic bonds. Now, to examine how metallic bonds are actually formed, let's discuss a specific type of solid metal known as solid sodium that consists only of sodium atoms. So let's begin our discussion by examining our individual sodium atoms. So if we take a neutral sodium atom, that sodium atom consists of 11 protons found in the nucleus of that atom and 11 electrons found are outside that nucleus. Now 10 of these 11 electrons compose a very stable low in energy inner shell that has a symmetrical spherical shape, and the final electron is found somewhere outside that inner shell. So this outer electron, we say, is found in the outer shell of our sodium atom. Now, because we have 10 electrons found in the inner shell, these 10 electrons basically shield most of the positive nuclear charge found inside the nucleus of the sodium atom. And that means the positive effective nuclear charge that the outer electron feels decreases, and this decreases the force with which our outer electron is actually held. So that means the outer electron of our sodium atom is held by a very weak electric force. So once again, sodium atoms have a single electron in the outer shell and 10 electrons inside the inner shell of that sodium atom. Now these 10 electrons shield most of the positive nuclear charge of the nucleus from that single outer electron, and this drastically decreases the strength with which the outer electron is actually held. And this is true for every one of our individual sodium atoms found inside our solid sodium metal. So basically we have these atomic nuclei of our sodium atom shown by red. So that's the region where we have our protons and neutrons. And then we have the inner shell as well as the one electron found on the outer shell. And the electron densities of our outer shell basically combine, and all these atoms combine their electron densities, forming the following blue region. And because those electrons are held very weakly, that electron of each atom can basically move everywhere and anywhere within that entire solid sodium metal. So, once again, as a result of the overlap of the electron probability distributions of all the atoms, and as a result of the fact that each atom holds the outer electron of that atom very weakly by very weak electric forces, that means that the outer electron can actually roam freely about the entire solid metal. And these bonds are known as metallic bonds. So the bond energy of metallic bonds is about 1 to 3 electron volts, which is relatively weak if we compare it to the bonds that are formed in other solids, such as the ionic bonds and covalent bonds that exist in other solids, which have an energy of about 5 to 10 electron volts. Now, as a result of these metallic bonds, solid metals have very interesting properties. So, since the outer electrons of metals can move freely around the entire solid, metals typically demonstrate two very important things. So, metals have a high electric conductivity and they're shiny, so they exhibit something called luster. So, why exactly can they actually conduct electricity? Remember, whenever a molecule or whenever a solid conducts electricity, that basically means it allows the pathway for electrons to flow from one end to a second end. Now, in order for objects to actually conduct electricity, the material must readily allow the flow of electrons through that material. And metals conduct electricity well because their outer electrons can basically roam freely about the entire solid metal. Now let's examine shininess. Why exactly do metals have luster? Well, since electrons in metals are held by weak electrostatic forces by their nuclei, these electrons can oscillate with all sorts of frequency values. Now, when light shines on the metal surface, the surface electrons, these outer electrons, which are basically moving about with all different types of frequencies, can vibrate with the same frequency as that light. And when they re-emit that light, they re-emit the light at the same exact frequency, so that means our metal can readily reflect light of the same color. Now, this idea described in this lecture, that electrons can move freely about the entire solid metal and that creates those metallic bonds, is known as the free electron theory of metals. And we're going to discuss this in greater detail in the next several lectures.